Good evening. It's Miss Bradford. I'm going to show you how to do Boyle's Law calculations. Hopefully this will help with your homework. And if you hear yelling in the background, it is my son playing a video game, so please excuse. All right, so the first example problem I have says methane gas is compressed isothermally from 1 atm to 1.75 atm. The 1 atm is the initial pressure, so you write it right here. Let's see. All right, and the 1.75 is the final pressure. Then it says the initial volume was 20 liters. So I'm going to write that right here. And then in order to find out what the final volume is, we're going to use this equation. P1V1 equals P2V2. Initial pressure times initial volume, set it equal to the final pressure times the final volume. And we're going to plug the numbers in and solve. So our initial pressure is 1 atm. Our initial volume is 20 milliliters. Those two numbers have to be on the same side of the equation or you get the problem wrong. The final volume is 1.75, and I'm going to call, the final pressure. The final volume I'm going to call X because that's what you're looking for. So you multiply these two numbers together to get 20 again because 20 times 1 is 20. Set that equal to 1.75x, and then just like in algebra, you divide 1.75 into both sides. And when you do that math on your calculator, the final volume is going to turn out to be 11.4. Now there's the question of units. What units do you make this volume? Well, the initial volume was in liters, so your final volume is going to be in liters. All right? So let's go now and do a second example. Nitrogen gas expands isothermally from 10 centimeters cubed to 25 centimeters cubed. Centimeters cubed is a volume unit. So we put 10 here for the initial, and for the final we have 25. Okay? The initial pressure is 2.0 times 10 to the fifth. I'm going to write that times 10 to the fifth with an E. So it's going to be 2.0 E to the 5. Remember, E is the same thing as times 10. It's an exponent. Now I have everything ready, and the pressure that I'm looking for is the final pressure. It's X. So now I'm going to plug everything into the formula. Again, the formula is P1V1 equals P2V2. All right. The initial pressure, let me give myself a little room and right over here, is 2.0 E to the fifth times 10. Set that equal to the final pressure. I don't know. I'm going to call that X. And the final volume is 25. All right. When you multiply this together, you get these two numbers are going to be divided by 25. And so X ends up being equal to 8.0 times 10 to the fourth. And the units, PA. All right. And what I did mathematically was take 2.0 times 10 to the fifth, multiplied that by 10, and then divided by 25 to solve for X. And remember, when you're putting your exponents in your calculator, please don't use the caret 5 because that's telling the calculator to do something different. You want to hit that second EE button so that you're telling the calculator times 10. All right, let's go to the next example. We have a balloon of hydrogen. It's put in a vacuum. The initial pressure and volume of the hydrogen is 0.95 atm and 0.55 liters. So they tell you that the initial pressure and volume are all together. So 0.95, that's the initial pressure, and 0.55 is the initial volume. Final volume is 1.22. How do I know that's a volume? It says final volume right there, and I also have the units of liters. So I'm looking for the final pressure. Again, the equation is P1V1 equals P2V2. I'm going to put 0.95, multiply that by 0.55, set that equal to, I don't know P2, so that's my X. And I'm going to put 1.22 here because I do know my final volume. All right, so I'm going to multiply these two guys, 0.95 times 0.55, and divide that by 1.22. And when I solve that, X is going to be equal to 0.43. Now the question is, what are my units? I'm looking for pressure. The initial pressure was in ATM, so the final pressure is going to be in ATM. Okay? Last example. We have a student collects an experimental gas, has a volume of 730 milliliters at 101 kPa. So I have 730 milliliters and 101 kPa. So I have an initial pressure and initial volume. And then it says, what will the volume be? So I don't know the volume. I'm going to call that X. If my pressure, my final pressure is 202. So I'm going to double the pressure. What's going to happen to my volume? The equation does not change. We're going to plug everything in. So that's going to be 101 times 730, and that's going to be set equal to 202. I don't know that final volume, so that's my X. That's my unknown. And then to solve for that, divide both sides by 202. So you take 101 times 730 and divide it by 202. X is going to equal, one second. X is going to equal 365, and that's a volume. So what are my units? Well, if the initial volume was in milliliters, the final volume is in milliliters. All right. I hope that helps.